Good morning. So today we get to talk about something referred to as colligative properties. And there are four different colligative properties. We're going to focus in on two of them, but I want you aware of all of them. Colligative properties can be vapor pressure changes, osmotic pressure changes, changes in boiling point, and changes in freezing point. These are the four colligative properties. We're going to focus in today in our class on these last two. Okay, so what colligative properties are something that it's a phenomenon that we observe when you make a solution. So when you dissolve a substance in a liquid, you change that liquid's vapor pressure, osmotic pressure, boiling point, and freezing point. We use this in everyday life, both on the freezing and the boiling point. Places that you would have seen this used is, first off, if you're boiling a pot of water to boil spaghetti in, you very often will put some salt in the water. Now, my husband used to say that he did this to speed up the boiling. That's not true. You put the salt in to flavor the pasta. This is your chance to flavor the pasta. But what it does is it actually makes the water boil at a higher temperature. It takes more to get it to start boiling. Another place you'll see this used is especially back in the Midwest and the Northeast, where there's a lot of snow and ice on the roads in the wintertime. They will put salt down on the road, and this causes the snow that's falling and the ice that's falling to melt because it lowers the freezing point. It has to get colder in order for that to freeze up. And so now you have water on the road rather than ice or snow, which is easier to travel on. Remember, a salt isn't just sodium chloride. It's any ionic substance. And that's going to become important as we look at this in calculation form. So what we can do is we can predict how much a solution's boiling point or freezing point is going to change based on how much solute we dissolved. We can also predict how much solute we need to dissolve if we know how much we want that boiling point or freezing point to change. And the way we do this is by using a formula. The formula is delta T equals K, which is a constant, times M, which is your molality, times N, which is the number of particles your solute dissolves into. So let's talk about this. This K can either be a boiling point constant, in which it's referred to as KB, or it can be a freezing point constant when it's referred to as KF. Every liquid that is a solvent has a boiling point constant that never changes, and it has a freezing point constant that never changes. These two numbers are different, but they're used in the same place, depending. I guess I should have made this T a capital T because we always have temperature as a capital T. Okay, so this lowercase m, I hope you remember from last week, is molality. Molality is a measure of concentration. Remember, it's calculated moles of solute over kilograms of solvent. Very important you remember it's kilograms of the solvent. And then this N is number of particles that it dissolves into. If your solute is covalent, then N equals 1, always. Doesn't matter what covalent compound you're dissolving into your liquid, your N is always going to be a 1. Now, if this is ionic, N is going to equal the number of ions that exist. So let's look at this. Something like sodium chloride, you have your sodium ion and your chloride ion. N is going to equal 2. Well, what about calcium bromide? You've got calcium ion, but now you've got 2 bromine ions. So therefore, your N would equal 3. Okay. What about something like sodium sulfate? Remember, sulfate is your polyatomic ion. So therefore, the sulfate ion, that SO4, stays as 1 ion. But now you have 2 sodium ions. So your N would equal 3. Okay? Key background information you need to know in order to be able to do these calculations.